Hey there, this is Seth Schaefer from Team Just Cause Robotics. This is Division, one of the largest vertical spinners that ever competed in the 3-pound weight class. Probably not the biggest, but certainly one of them. And this is the weapon from my 12-pounder integration. It is almost 16 inches in effective diameter. Simone Yetch may be the queen of shitty robots, but king me. This is one of the dumbest things that I have ever built. Ordinarily, I'd show you the entire robot that was built before doing an event recap like this, but I was so infuriated with how bad it was that I disassembled the entire thing pretty much as soon as I got home after the competition. Integration competed in the 12-pound weight class at NHRL on March 1st. Hey there! Different day, Seth again. I wanted to acknowledge that I really screwed up with the first cut of this video that I released, and I deeply apologize to both all of my viewers, but more certainly the builder that I had disparaged in that first video. I was treating them very unfairly, given the circumstances of everything, and after talking with them, learning some additional context behind what exactly happened, and also just realizing from rewatching the video myself that I came across far more negative and far more harsh than I had intended to, I've decided to delist the original video and replace it with this one. And in this video, I want to, first of all, be generally a lot more positive because this channel is about trying to help new builders get into the sport. And a lot of the mistakes that I believe were made with the design of the robot that I purchased ended up being the kinds of mistakes that it's very easy for a new builder to make. So I want to take the opportunity to discuss how to avoid making mistakes or fixing problems that can easily come up with a design of a bot, rather than just talking about how bad of a job might have been done on certain aspects of the previous design. On top of that, I also want to acknowledge a lot of additional context that I didn't give in that first video. Most importantly, the robot that I purchased was known as Deep 0.6. I purchased the bot for $600 plus a couple $100 worth of robot parts after it was listed on Facebook originally at $1,000, and the builder messaged me because I'd expressed interest since it's a scaled down version of Deep 6, the 250-pound heavyweight, obviously. Now, the Deep 0.6, when I purchased it, came with two different CAD models. There were 3D models that were produced by the builder I purchased the robot from, entitled Deep 0.6, but there were also design files from another builder, Andrew Rossol. Andrew Rossol is actually a member of the Deep Six Battlebots team, and he designed a 15-pound version of Deep Six that he entitled Nautical Nonsense. Now, Nautical Nonsense was not a completely finished CAD design. In fact, I'll show it to you right now. The version of CAD that Andrew had made, he decided never to actually build the robot, and there were a lot of unfinished aspects of the design that ended up carrying over into the design that I purchased, but ultimately these were more oversights than outright mistakes on the part of the builder that I bought the robot from. So I'll switch over to my overlay view here. So this is what the 15-pound Nautical Nonsense CAD looks like that I received. I didn't hide the top plates, there just are none, they were never designed. You'll notice that everything is kind of held together with nut strip, but there are no holes to hold the back panel in place, those just weren't added. I'm not saying this to disparage Andrew in any way, it's just obvious that he got reasonably far in the design before deciding not to go through with actually building the rest of the robot, so he never bothered to finish the CAD. I'm sure that many of us builders have unfinished designs like this that we abandoned for whatever reason. And he ended up building a different robot that is called Nautical Nonsense, but is just a two-wheel drive wedge robot that competed at the Maker Faire Orlando event, which is one of the few events in the country that was running 15-pound robots at the time, although now, present day, it only runs 12-pound because they decided to standardize back to the more common weight class. So this design was obviously like all sheet metal, thin sheet metal for everything, and I don't have the ability to weld, and I don't think that the builder of Deep Six did either, so they, I think, smartly decided to change it over to half-inch thick UOcean W design. So this is the version of the CAD that I received. I just set the opacity of the top plates to like 60% so you could see what the insides look like. There's no battery designed in or anything, but that's not a big deal. But essentially this is what I received. And so this is what I based my version off of. And I also received basically every part that you see here. I did not receive a battery, but I did also receive a weapon speed controller that I mentioned in the last video, which was a sketchy Chinese brand Aphiz Queen 100 that I'd never heard of before and was really big and heavy, so I ended up replacing it with a VGood 120 amp. But yeah, I had the BaneBots wheels, I had the hubs, I think he sent me 6 drive motors in total, which is like $360 worth of just the drive motors alone. I got a drive speed controller that when I tried to desolder it fell apart and I couldn't use anymore, but that's not that original builder's fault. That was the design flaw with the repeat dual ESC or the early versions of it. And yeah, so I wanted to point out basically a couple of the issues here I think just stemmed from the fact that they just thickened parts that were already designed in the original. So like here, you can see there's square corners on these parts, which for a laser cut thin steel part isn't a huge deal. But when you scale it up to a thick plastic part that needs to be CNC routed, you run into some DFM issues pretty quick because you can't actually CNC route a square corner. This is one of the issues I brought up in that first video. This is an end mill, which is what a CNC router uses to actually cut things with. And you'll notice, if I switch back to my only camera view, this is a circle. And so it's coming and spinning and cutting. This is one of the original parts I was sent, which is recycled UOcean W. I decided to remachine all the parts, partly because things, while they did fit together, they were a little annoying to fit together because of this issue. When you want to cut a square slot with a circular tool, you end up with these corner radii in the tool. So to fix this, you have to dog bone the corners, which is what I did with this version of the part, where the tool can go in past, well I did it with an 1/8 inch end mill, not a 6mm rear one I'm holding, but you come in past the corner and then you can have an actual square slot. So the parts that have to fit into it can be machined just lying flat on the table. You don't have to like round over these corners to make them fit. And then on these parts I also went past the corner to notch them out so that these fit nicely square peg into square hole. That wasn't the case for the original parts I was sent. Instead, they had a square tab that had to be sanded on all of those rounded corners to make them fit, which meant that no two parts fit together perfectly, and they weren't really interchangeable, which is a bit of a problem for a combat robot where you need to have spare parts you can swap in and out. So I just decided to go ahead and remachine everything, partly because of that, and also partly because I didn't want to use the recycled UOcean W anyway, and also partly because I just didn't like the amount of pocketing that was done, especially down here where the this mounts to the base plate. I mean, you've got this nut strip here that's holding on to it with just this thin strip of material here. Whoops, I'm not showing this. I also partly didn't like that you've got just so much pocketing on the uprights. Like, there's just this thin strip of material here, but it's all attached to the nut strip. And then there's nothing really supporting it other than this very, very small tab into a slot onto the back panel. This back panel is only an 1/8 inch thick. And I don't love that is like the only thing preventing the uprights from just parallelogramming. So I wanted to make this pocket significantly smaller, which is what I did on my redesign. I kind of changed it to this just big enough for the pulley slot, and then adding some different cutouts in different places so that there was overall a lot more material left on the uprights to make them a bit stiffer. And then I also switched the material to V H&W instead of U H&W, which I thought was going to be a stiffer, cheaper, but not that much worse alternative to U H&W. Turns out it's actually way worse. It's horrible, and I would 0 out of 10 never recommend using it for anything ever in combat, because while it is actually surprisingly very stiff for a plastic, like I'm trying as hard as I can to bend this part and it just barely bends, it also stays bent when it gets hit and stays deformed, and it's just not good for combat purposes. Like, you can see this front piece is just like completely caved and it's staying like that, which a UH&W part would have just bent back, but this is now a banana forever. So definitely didn't love that. Let's see, what else? The weapon assembly. This was one of the major complaints that I had with the previous version, but now looking at the Nautical Nonsense design, I can kind of sort of see where some of the issues came from, and looking back at the original Deep Six CAD model as well. So this is the weapon pulley that I was sent, and originally it was designed so that this cylindrical part has an exactly 0.75 inch diameter, and the bore in the weapon has an exactly 0.75 inch diameter. Very common design for manufacturing issue. When you make two parts exactly the same size, they just won't fit together. You need to have clearance for the parts to slide together, or at least design an engineering fit like a slip fit or something. But these ended up being machined not exactly perfectly, because laser cut parts like the blade are usually going to come out a little bit wonky, especially with a blade this thick. There's usually laser cut taper, so the part will end up with an undersized hole. And that led to the pulley and the weapon interfacing way too strongly together, and the aluminum on the hub was peeling apart. I had to like hammer them apart and sand the outer diameter to get them to fit properly. Another issue is the inside bore is way too big. That, I think, was just a series of CAD errors that resulted in the hole being the wrong size, because Nautical Nonsense's CAD has needle roller bearings instead of the bushing, and the inside bore of the pulley here is, well, I have to switch it back to inches. This is a 1.25 inch diameter, and the Deep Six CAD 1.0611 inch diameter, which I don't know where that measurement came from, but it's not the diameter that the bushing is. So there was a 3D printed TPU sleeve between the bushing and the weapon hub, which meant that there was some extra play in that assembly that I didn't like. So my solution to this problem was to go to today's video sponsor, PCBWay, to get this pulley made. So this not only was intended to solve the bushing fit issue, but also I wanted to use a wider belt, a 3L belt instead of a 2L belt, just because I felt that was more appropriate for the load that the bot experienced. Now, obviously, you saw in the intro video, I was able to self-right the robot without this, but I thought this would have made my life a lot easier, and especially because I could actually buy metal pulleys to run on the motor shaft that would have worked with this size of belt, but couldn't find any that would work with the thinner belt in time, and that meant I ended up not being able to get the robot to actually have a really reliable weapon, because come competition time, unfortunately, this part wasn't able to be shipped by PCBWay in time due to delays from the Chinese New Year. Even though I ordered the part in late January, they weren't able to get it ready in time for March 1st. So unfortunately, I only received these parts on March 14th. And I had to scramble with finding out on the Monday before the competition that I couldn't use my 3L belt setup that I had planned around. I had to scramble to try and figure something out. I ended up 3D printing pulleys for the motor side, and they didn't quite work the way that I had intended. I'll show you kind of what I had here. So this is another pro tip for robot design stuff that I learned from Owen Coakley from RECR Robotics, is parametric text. So there's a parametric text add-on for Fusion 360, and I set the outer diameter and width of the belt as parameters that affect this text. So if I go into my parametric text menu, I can change this to like 1.7, and then it updates the actual pulley itself. You kind of couldn't see it there. If I change it to 1.85, updates the pulley, and then when I hit OK, that text changes to 1.85. So I was able to 3D print a bunch of versions of this that were all labeled to test with. And of course also change to 0.375 inch diameter belt, or width belt. And then boom, that text updates and the width of the actual pulley groove updates as well. So that's a really handy tip for you if you're looking to prototype and get the exact right belt fitment for your V-belt drive. Print a bunch of diameters of pulleys like I did, and you can hopefully find one that works. Sadly though, I had so little time, and you know, printing the pulley still takes like a couple hours each pulley. I printed a bunch, and then I had some cogged V-belts that I got from Amazon that arrived on Thursday before the event, and the belts were like too flexible. They were flipping upside down when I did a spin-up test. I'll probably show a video on screen. And so I ordered some regular non-cogged belts straight to NHRL, and those were significantly tighter despite being the same length. This should not be at the angle that it's at, but it still spun up the weapon, and I can't do anything about it now. I'm gonna fight in like 10 minutes, so I guess it'll have to do. This is apparently a known problem when I talk to some builders at the event. Very common known issue with V-belts is the lengths just aren't the same, and you need to have some sort of adjustability in your system. And unfortunately, the smallest diameter pulleys that I had printed were 1.8 inches, and they were still too tight. So I had somebody at the Airbnb that we were staying at, because the whole Bloodsport team kind of went to the March 1st event together. A bunch of WPI guys from the Fireball team and a bunch of us from the Bloodsport team together. In the Airbnb, we happened to have a P1S 3D printer and some glass fiber nylon filament. So I had them print a pulley that I hoped would work the night of the Friday night, so the night before the tournament, show up on Saturday morning to fit it, and unfortunately it was still like pretty much a bit too tight. So there's a 1.8 inch on here, and I did a 1.8 and 1.9, but the 1.8s are still really tight, like really quite tight. But basically my hope is I can actually seat the motor properly and like put all 4 screws in and like seat it properly, but it's still at an angle. I might have to re-tap the threads on the other side or flip the motor. Either way though, it's looking better than it was, because I can actually get screws to thread into the motor while the belt and pulley are on. This belt has so little stretch to it. It's really tight. As you can see, the whole motor is moving as I touch this because it's not locked down properly. So that's the biggest problem to solve, is trying to get the weapon reliability to be decent. And then the other problem is the stiffness of these pieces isn't sufficient. So instead of just rocking onto its wheels, these were, if it goes all the way back, these were like bending over. I have a quick fix for that, which was to get some threaded rod from Home Depot at 6 a.m. and kind of use the drill to spin it through. That seems to have helped quite a bit. It's not perfect. And then Glenn from Caldera here is letting me use his 3D printer to print these parts, which I tried to print last night, but we didn't have enough glue stick on the bed and they wouldn't stick. And those are going to be similar to this, but completely solid in the middle, and with like a rib that sticks out to stiffen it laterally. So hopefully that will help. And if not, then I've got this threaded rod solution as a bodge fix. And that pulley also split in half in my first fight, so it probably wasn't properly dried filament. Again, with the super last minute nature of these fixes, I just didn't really have time to get the bot fully working. So self-writing is another aspect in which I improved upon the Deep 0.6 design with integration. And to do that, I basically just copy-pasted what the 30-pounder Overlord did. Jillian from the Bot Barons team that designed Overlord, which got second place at Motorama in 2025, by the way. Awesome 30-pound bot, which is also a huge big vert. They designed these curved back pieces. They're maybe not the original area of the design. You could argue that Brandon Bennett Young with Phenomenon/Vorion came up with the design first, and I'm sure there were many people who did it before him as well. But basically the idea is you want it to naturally want to roll back onto its wheels when it tips backwards. And to ensure that, you basically just need to ensure that the center of mass is getting progressively closer to the ground along that curve. Because you can imagine if I made this a circle directly around the center of mass, then it could balance perfectly in theory and not want to roll back onto its wheels. So you can see here, basically this curve follows such that it's like 157 millimeters at the very end there, and only 133 millimeters at the end here. So it's about an inch closer to, the center mass is about an inch closer to the floor when it rolls towards the wheels. And that way, gravity will naturally pull it back onto its wheels if it tips backwards. And the blade will be able to generally get it into a position where it's resting on its back. Even if it's lying flat on its front, I was able to get it to have enough torque to do that, as you saw in the intro. So that worked pretty well, and would have continued to work well at the competition had I actually been able to keep the damn belt on. Hopefully, all of that wasn't too terribly boring, and a little bit more informational on how to solve some of these kinds of problems moving forward. Ultimately, I think what made integration not do very well was really just that it was rushed. Part of that was because the robot was shipped to me a bit late. The builder that I purchased it from was sick right after I bought it in November. I didn't receive the bot until January. But part of it was that I just decided to sign up for the March 1st event, and I could have easily not done that and signed up for a much later event. I just thought that I had plenty of time based on when I had originally decided to make the purchase, and ended up having a lot less time than I thought. Sometimes it do be that way. Now, realistically, a lot of you skipped this timestamp anyway, so let's just get on with the fights, shall we? Now, if it somehow wasn't obvious, integration is very obviously a glass cannon one-hit wonder kind of bot. And that means that it's designed to deliver one really huge punch to the opponent, pray that it somehow survives delivering that hit itself, and that the opponent has died horribly. So imagine how I felt when I found out my first fight was going to be against a multi-bot, where I'd have to knock out 2 robots in order to win the fight. I had to fight the Honey Bombers up first, a brand new multi-bot with 2, I think 8-pound robots competing together in the 12-pound weight class because of NHRL's weird multi-bot weight bonus rules. The Honey Bombers consisted of a vertical spinner and a horizontal spinner. I was actually much more scared of the horizontal spinner because their blade is kind of like an undercutter style blade, really low to the ground, and I didn't think that my weapon would be able to make contact with it, and so I didn't think there was pretty much anything I could really do to really hurt the horizontal half of the bot. But I was hoping I could go straight into the vertical spinner half and like punt it across the arena with a good solid hit at the beginning, and hopefully take it out of commission so I could focus on pointing at the horizontal for the rest of the fight. That said, I ran into some drive problems pretty early on in my testing. Turns out that a 3D printed TPU strips out really easily on the hex shafts from the Repeat Ultras. I was hoping I could just shove a hex on that was undersized in TPU onto the steel hex of the shaft and it would just work. And while it did work in my testing at home, as soon as I got to the test box at the competition, I was able to round out the inside of a hub. So I swapped to a fresh pair of wheels and just hoped for the best, but yeah, you'll see how that went.
Giant spinning weapon from Seth Schaefer. We've seen it before, but never this big.
Never this big? It feels ominous, Kyle. I don't know what to expect here.
The orange and white color scheme, though, makes it seem a little whimsical, but with the spikes, the death spikes up the back, the roll bars, it's very intimidating.
Just to lull you into complacency, but I don't think that's going to work on the Honey Bombers.
5,
Honey Bombers looking vicious. We've got big old tracked wheels. We've got big old yellow weapons. But will the weight disparity be a huge disadvantage against that human?
Did a great job avoiding that blade in that first mini. Oh! My God.
Oh, the belt's off. No belt on integration anymore. It is now the Honey Bombers match to lose. All they have to do is keep the assault going. Honey Bombers doing a little dance over there in the corner.
A little early for a victory dance.
Now, what is the name of these bots, Lindsay, the two Honey Bombers?
So the horizontal is Reaper, the vertical is Venom, and they are watching. Is getting counted out.
And there it is, baby.
So yeah, that was terrible. First of all, this is what the base plate looks like now. There was this much material, which is already not enough, and now there's this much material. This is only an 1/8 inch thick, by the way, aluminum. And yeah, it's nowhere near adequate for the amount of damage that a 12-pounder can dish out, let alone even this 8-pounder was able to punch a hole straight through it. So yeah. After that fight, the frame was bent out of shape, fork was destroyed, the uprights were messed up. I had to swap out the forks, and I ended up having to switch weapon pulleys because the weapon pulleys split in half. The wheels, again, cammed out the inside of the hubs, or sorry, the drive axles cammed out the inside of the wheel hubs, so I had to toss those wheels and switch to fresh ones. I was able to actually talk to the Honeycraft team, and they were able to give me some aluminum clamping hex hubs to go onto the shafts, so they kind of saved my butt, thanks to them. For the next fight, at least I could get the bot driving properly, but that weapon assembly just wasn't working in its current state. The pulleys that I ran in that first fight were 3D printed in the Airbnb the night before the competition with filament that wasn't properly dried. And so I switched to ones that I had printed at home, but that were a little bit tighter, and well, the first set was already kind of too tight. This set was really, really pushing it. I had to switch to longer screws to bolt the motor on and more of a thick spacer underneath to kind of sort of get it to work, but it was really sketchy. And the biggest problem was that I wasn't sure if the pulley would survive because, again, with PCBWay having not shipped me my original 3L pulley in time, I had only purchased a 3L sized motor pulley that was metal to work with it, and I had to use these 3D printed ones on the motor to fit a 2L belt since I couldn't find a 2L belt pulley in the correct size that was made of metal that would fit on the shaft that I had in the like 1 week that I had after finding out I wouldn't get the PCBWay pulley in time. So just everything about this bot was just kind of a disaster with all this last minute stuff going wrong. But eventually, somehow, I was able to get it back together to fight a second time. My next opponent ended up being Torrent, which is an extremely highly competitive beater bar bot. I was praying with one solid hit to their weapon assembly that it would break. He was frantically working on fixing the robot in the pits beforehand. The weapon wasn't even working at first, but they ended up not forfeiting and instead actually getting the bot together, and we got into the arena together, and, well, this is what happened.
Like a Klingon warbird. It is just absolute death on two wheels.
It's so cool. I like that blade shape, too. Just like a hammer.
No, it's so good. Now, Seth Schaefer had a robot in the 3-pound division called D-Vision that was a very similar style robot to this. Big, tall blade, and he was really able to get a lot of control over that machine. Will that translate to this 12-pound weight class? So far today, we've just seen a lot of chaos and broken belts, so we'll have to see.
Oh, no, belt off
Yeah.
on integration. That was fast. Oh, no, and doing the thing.
Still working out the kinks on this design. By the way, all the kinks have been worked out of Torrent.
Come on, Torrent.
Oh yeah, a little bit of tacoing on the body of integration there as well. See that?
Jeez, yeah.
Yeah, that's not great.
He got pringled.
Donald Sung, just a fantastic driver. Kind of an older style of robot in Torrent, right? That longer body, that small weapon at the front, 4-wheel drive, but that's what he likes. That's his jam.
So yeah, a pair of 30-second fights is all integration had in it. Unfortunately, without a metal pulley on the motor, it was just impossible to keep that belt on. The pulleys were exploding, and there wasn't anything that I could do about it with the lead time that I had. So that was it. 0-2. Really, really disappointing and frustrating with how much work went into the bot in the 2 months leading up to the event, and once I was there, of course, as well. But that's how it goes sometimes. A very experimental robot with a lot of experimental bot problems is just not going to work out every time. But I've got plans to completely ground up redesign integration. I'll probably keep the name just because it fits with the theme with division and subtraction, but it'll be nothing like what you saw in that first event, that's for sure. So make sure to subscribe and hit the bell icon so you can get notified when those videos come out. I'll have plenty more event recaps coming up. I've got like 2 or 3 that I haven't done yet for competitions that have happened already. So those will be coming out hopefully in the next 2 or 3 months. And that's all I've got for you today. So thank you so much for watching. Bye-bye.